Auzubillahi Bismillahirrahmanirrahim. Start with the name of Allah Almighty, who is the most beneficent and merciful. First of all, I want to say Assalamu alaikum to everyone. I hope that all of you will be fine. So, dear students, in this video we are going to discuss about the collision theories of the rate of reaction. So, first of all, we will discuss about the types of the collision theories of the rate of the reaction. So, I want to tell you about some important points about the collision theories. So, collision theories must be proposed to explain the rate of the chemical reactions. What thing which explained by the collision theories? Collision theories explain that how reactants is occurred. In a chemical reactions, the reactants are react with each other to form a product. So, due to explain this reaction, due to explain this reason, how reactants are react with each other and form a products. How reactants are react with each other to form a fruitful products. So, how we can explain the fruitful reactions and unfruitful reactions. So, due to these reasons, collision theory must be proposed. So, there are two types of the collision theories. So, first type of the collision theory is called the bimolecular collision theory. And the second type of the collision theory is called the transition state theory. So, in this video, we will discuss about the bimolecular collision theory. So, in a bimolecular collision theory, there are two molecules. Those are react with each other to form a product. Given by the name bimolecular. So, the name bimolecular means there are two molecules. Those are react with each other to give this product. So, now we will discuss about the assumptions of the collision theory at a first type bimolecular collision theory. So, the first assumption of the bimolecular collision theory is that for a reaction, molecules should be collided. For a reaction, molecules should be collided. Are reactions which can be occurred when the two molecules are react with each other. Those reactions in which the two molecules are react with each other to form a product, those are also called a fruitful reaction. But those reactions in which the two molecules do not react with each other, these molecules do not have ability to react with each other, do not form a product, these are called unfruitful reactions. So, for a reaction to be occurred, molecules must be activated, molecules must have a sufficient amount of energy which is greater than the activation energy. So, these are the conditions for a molecules to be react. So, first assumption of the bimolecular collision theory is that for a reaction, molecules should be collided with each other. Or you can say that for a reaction to be occurred, molecules should be collided with each other. The second assumption of the bimolecular collision theory is that the reactions in which the molecules collide with each other, the reactions in which the molecules collide with each other is called the fruitful reactions. Those reactions in which the molecules are react with each other, those reactions in which the molecules have ability to react with each other, and those reactions in which the molecules have ability to form a product, those are called the fruitful reactions. But all the reactions are not fruitful. All the reactions are not fruitful. There are some type of the reactions in which the molecules do not have ability to react. Those reactions in which the molecules do not have a sufficient amount of energy to react. So, those are called the unfruitful reactions. So, the third assumption of the bimolecular collision theory is that the molecules must possess sufficient amount of energy to be react with each other to form a product. So, in a reactions, two molecules must have a sufficient amount of energy to be react to form a product. So, the fourth assumption of the bimolecular collision theory is that the molecule must collide in a correct orientation. It means that the molecules should be collided in a line-to-line segments or head-to-head approach. Then these collisions may be fruitful or products are formed. So, let us consider there are two reactants, two species, A species and B species. These species are react with each other to form a product. So the rate of the reactions is given as dN over dt, which is equal to Z e raised to power minus EA over RT. What is N? N is the number of the molecules. In a bimolecular equation theory, this is the theory of the two molecules, so value of the N is 2. Then the rate of the reaction becomes dN over dt, which is equal to Z e raised to power minus EA over RT. What is Z? Z is the number of the collisions at a per second, at a per time, at a per unit volume. And E is the bimolecular collision factor. In a bimolecular collision factor, EA is the activation energy of the molecules. Activation energy of the molecules may be defined as the amount of the energy which is required toward the molecule, the amount of the energy which is required for the molecules to cross the energy barrier is called activation energy. Or you can say that the amount of the energy which is required for a molecules to be activated is called the activation energy. R is called the general gas constant and T is called the temperature. So temperature is also affect the rate of the reaction in a bimolecular equation theory. If we increase or decrease the rate of the temperature, then the rate of the reaction is also affected. So if we write this equation in a number of the moles of the reactant A and B, let we suppose the number of moles of the reactant A is Na and the reactant B is Nb. Then the rate of the reaction can be written as dN over dt, which is equal to K into NaNb. So this equation becomes K, which is equal to Z over NaNb e raised to power minus Ea over RT. So this is the final equation of the bimolecular equation theory. I hope that you would have a lot of knowledge about this topic. So at our next video we will discuss about the transition state theory.